let's start deployment script. So first, as already mentioned, we need to connect camera to the discovery board. Then we need to open Windows PowerShell console. Our board is set in development boot mode, as you can see on the slide. So I'm starting the script. First, I need to go to the Model Zoo Services repository target folder, so the object detection folder. And now I can start the script. So in order to remind you, as already mentioned, the entry for the user YAML script, it is the Python application STM32 AI_main.py, which is present in the object detection folder and also in another use case folders. So let me show you what is behind the script. So I'm opening Model Zoo Services repository. Then I'm going to the object detection folder. Then I'm going to SRC folder. And here you can find config file examples. And by default, there are several scripts, examples for different use cases, operation-wise, and also showing how to chain the operations of the Model Zoo services. And our script, it is here, deployment N6 config muk tiny YOLO v2 YAML. As you can see also here, deployment N6 config muk tiny YOLO v2 YAML. I prepared this script based on similar examples. So I'm going to open. And this is the script, not so complex. You can see there are the sections: general, dataset, pre-processing, post-processing, tools, deployment, MLflow, and Hydra. So the general section, in the general section, you need to specify the path to your model, and your model is present in the application code use case model subfolder here. So quantize tiny YOLO v2. Then the model type name, operation deployment. We want to deploy our model on board. Then dataset. In this case, we have only one class, person. Then pre-processing implemented in the embedded application. So aspect ratio, crop ratio, crop, and interpolation nearest color mode RGB. Then post-processing, relevant for YOLO v2. Then tools, and in the tools section, you need to point the STHAI tool folder, and you need to point to the Cube ID folder. Then for deployment, you need to specify C project path, and this is the N6 subfolder of application code object detection subfolder. And you need to specify hardware, so this is N6 and discovery board of N6. Okay, so let's start our script. So it takes some time. We need to wait until we will see on the console info deployment complete. Please on the discovery board toggle the boot switches to the left, what means flash boot mode, and power cycle the board. In the meantime, I'm going to explain you where the results of the deployment process of Model Zoo services can be found, and it is even more generic because in this output subfolder you can find the results of each operation you execute using Model Zoo services. So not only deployment but also training, quantization, etc. So I'm coming back to the object detection use case of the Model Zoo services. Then again I'm entering SRC, and here you can find experiment outputs subfolder. So let's enter this, and here you see the timestamp folder name. So this is our timestamp. The current one is 22nd of October. Here, during tests, I deploy the model so we can see what is the result. So you can see both the folders and the files. The most important one is the folder generated, where you can see the source code generated by the script. Network.c, this file describes the epoch content for the neural processing unit. Then here you can find the memory initializer, so the weights of the model. And here you can find in this header file network_ec blobs, you can find the operations for the epoch controller, for the hardware sequencer of the neural processing unit. So we can see here, once again, an excerpt of output of the deployment script, the most important folders. So in the generated subfolder, you can see the source code to be updated. In the C header, you can see app_config.h. This is the configuration file for the embedded application, where you can specify the input resolution, the model supported, etc. So it will be automatically updated. Then also interesting file, it is c_info.json. This JSON file can be found in the Neural Art Network subfolder, and this file describes the generated model structure. In this JSON file, you can find quite interesting informations, because in the JSON file there are properties, the following properties, for example, environment, so it is description of the environment used to generate the model, information of allocated buffers, then information about the layers of the model, the memory pools, so the summary of the N6 memory pools used by the model, the characteristics of the memory accesses, power estimates, so it shows you the power consumption per epoch of the neural processing unit, information regarding validation, memory footprints, execution time, etc. So also the profiling of the model. Let's come back to the console. Now, as you can see on the screen, the script is flashing weights to the board, to the external flash. So we need to wait, because in this case it is quite a large file. Let's see. Here you can see about 11 megabytes of data. So it is finished. Both the embedded application, it is in RAM memory of the, and in RAM and in flash of the board, and the weights, the memory initializers are also in the external flash. So now I need to switch the boot mode to the flash boot mode. So switching boot 1 to the left position, and now the YOLO V2 model is running on my board. So let's see if it is visible in the source code. So I opened again the Cube IDE and the source code. So let's start from the configuration file. So now I can see the pop-up replace editor content. So it has been updated, and now you can see the supported model, it is YOLO V2. Also, it should be visible in the main.c. I need to update index. I need revealed index. Yes, and as you can see here, the post-process type also in main.c, it is YOLO V2. So the project is updated. On this slide, you can see all the files, all the log of the deployment script regarding update of the project. So the script updated network.c, so the content of the epochs executed by the neural processing unit, then network underscore ecblobs.h. So this is the information, the sequence of the operations for the neural processing unit sequencer in order to automatically execute all the epochs. Then the memory initializers file, the weights of the model has been updated. Then the AI runtime library for the Cortex-M55, because we need to consider that not all the layers, not all the operators of the model can be executed by neural processing unit. If not supported by hardware of the neural processing unit, then executed in software by core. Then we need to header files, API files for the software runtime library. Then we need to update the runtime library for the neural processing unit. We need to update the configuration file for the application and software runtime library itself, so the .a file. Script considers generic use case. So it considers that not only model is updated, but also a version of the runtime libraries can be updated. So for example, we can move from the STHAI 2.1 to STHAI 2.2. On the slide, you can see really generic use case. And it is described in this document here. So really generic use case. How to update my project with a new version of STHAI core. If version of the STHAI core is the same, when you need only update the model. So in this case, it is a little bit more simple. So we need to update only network.c, network ecblobs.h, and you need to flash new memory initializers. So thank you for your attention.